Hello students and friends, welcome to my channel. In this video, let us discuss one previous Iit-Jee advanced question from stereochemistry conversions. So the first structure, that is the M, is nothing but Sahos projection formula. So in this case, the Cl is downward direction and this methyl is also downward. So we can write as it is. That means here the Cl and CH3 on the vertical line. And here the first carbon, it is a, that means here this is of one carbon. Okay, this carbon is the top carbon. So your hydrogen on the right side, your OH on the left side. So we can write as easily. So it is a hydrogen and this is OH. Now on this carbon, your hydrogen on the right side, OH on the left side. So your OH and hydrogen. Now, so coming to this structure. In this structure also, methyl downward and this Cl also downward direction. So here in this case, this methyl and this chlorine on the vertical line in a Fisher projection. So here CH3 and this Cl and this carbon, hydrogen on the right side and this OH on the left side. So here this is the hydrogen and this is the OH. Now at this chiral carbon, OH on the right side, hydrogen on the left side. So here a hydrogen and this is the OH. Okay. So here in this case, this carbon attached to the chlorine and OH. So this chiral carbon is on the top and now this chiral carbon is on the downward. That means here this OH and this Cl and here OH here, this is the chiral carbon and this chiral carbon. These two are the same chiral carbons. So now here, what is the relation between these two structures? So just here rotate the structure. Okay, by rotating the configuration of groups is not changed. So Cl and CH3. Now by rotating the structure, the Cl, the OH which is on the right side, so comes to the left side. And here hydrogen left side, so comes to the right side. And next here at this chiral carbon, so H on the right side, so comes to the left side. And here OH on the left side comes to the right side. So just here this molecule is rotated in the plane. Okay, this molecule is rotated in the plane. So when molecule is rotated in the plane, the configuration of the chiral carbon is not changed. So now here, what is the relation between these two structures? So here in this case Cl and CH3 on the vertical line and here hydrogen on the right side, and in this case hydrogen on the right side. Now here this hydrogen on the right side, at this chiral carbon hydrogen on the right side, at this chiral carbon hydrogen on the left side. So here these two are the non-mirror images. So here the first option is the correct option. MN or non-mirror image stereoisomers. Okay, there is no these are not the mirror images, so these are not the enantiomers. So non-mirror image isomers. Now coming to the molecule O. So in this case, this Cl is given in upward direction. So by rotating this one, comes to the downward direction. So here, this is the vertical line again. So here by rotating 180 degrees, this OH comes to the left side and this hydrogen comes to the right side and this Cl comes to the downward. Now here remaining chiral carbon same, CH3 downward and hydrogen left side and this OH on the left side and hydrogen on the right side. Now here we can directly this structure into the 2D structure. So on the vertical, which groups are present? Just here Cl and CH3 groups are present. So here Cl and it is a CH3. So in this case here hydrogen on the right side, this one OH left side. So here this hydrogen and this is the OH. Now this OH left side and hydrogen on the right side. So this one hydrogen and this is the OH. Okay, so here this is the structure of M molecule and this is the structure of the O molecule. So your OH on the left side, your OH on the left side. So M and O exactly same. So here next option B is also correct option. And next here coming to the P. This is given in a Newman projection. So write the Sawhorse projection for this molecule. Okay. So here write a one tilted line. So generally here in this case it is a first carbon. That means it is a front carbon. So this front carbon methyl in upward direction. That means here this methyl in upward direction. And here hydrogen on the left side and hydrogen on the OH on the left side, hydrogen on the right side. Okay. And next here this Cl is in downward direction. And this is a circle carbon is a rare carbon. So this is the rare carbon. To this rare carbon chlorine is attached in downward direction. And next here hydrogen left side and OH on the right side. Okay. So this OH on the right side. Now in this case the Cl in downward direction and here this methyl is in upward direction. So here to bring this methyl in downward direction, rotate the molecule. So by rotating this molecule, this hydrogen and this is OH and this is Cl. Okay, by rotating this one, that methyl comes to the downward direction and this hydrogen upward direction and left side, and this OH group comes to the right side. Okay, now here we can write directly to the Fischer projection. So here Cl and CH3. So it is a Cl and CH3 on the vertical line. OH on the right side, here H on the left side, here OH on the right side, H on the left side. So that means here this is the hydrogen and OH, and this is the hydrogen and OH. Okay, so this is the structure P and this is the structure M. So M and P are the mirror images exactly, because here these two hydrogens on the left side, right side, these two hydrogens on the left side. So M and P are the exactly mirror images. That means here enantiomers. So here C option also correct option. Now we are coming to the Q molecule. So write the Newman projection formula for this compound. Sorry, Sawhorse projection formula. This CH3 is in upward direction. Now OH on the left side. Okay, it is a front chiral carbon. Okay, it is a front chiral carbon. Now this is a rare chiral carbon. So here OH on the rare chiral carbon, OH on the left side, and this hydrogen on the right side, and Cl downward direction. Okay, so now here this CH3 is in upward direction, so that must be brought to the downward direction. So here by rotating that chiral carbon, so here this OH and hydrogen, and this one is a Cl, so this is a CH3, so here a hydrogen and this is a OH. Okay, so by rotating this one, this hydrogen goes to the left, this OH comes to the right side, and CH3 in downward direction. Now this molecule we can write exactly in the 2D representation. So Cl and CH3. So in this case hydrogen on the right side, OH on the left side. So hydrogen and this is the OH. Okay, hydrogen and OH. So here hydrogen and OH. Okay, it is a structure of the Q molecule. So here last M and Q are identical. So in this case M and Q are not identical, because between M and Q molecule there is a change of configuration at one chiral carbon. So at this chiral carbon OH on the right side, at this OH on the left side, at this chiral carbon OH on the left side, but coming to this molecule here OH on the right left side, but here OH on the right side. So these are not identical, these are non-mirror images. Okay, not identical, not enantiomers. Of course, these are the diastereomers. Okay, so that is the previous IIT JEE advanced question. Thank you for watching. Please share the